This is BTEC Engineering, Unit 7, B11. We're on page 11 of the examples booklet. Now this is very similar to the examples earlier in the section. We're using definite integration to integrate a function to find a distance travelled. However, this function requires you to use a technique known as integration by substitution to be able to integrate it. So it's a very challenging example. Again, if you want to get merit or distinction, you're going to have to explain your method. To pass, you're going to need to be able to repeat this process with slightly different numbers. Right, so the integral we need to do is f equals the integral from 0 to pi over 2 of sine to the 4t cos t dt. And as a little aside, you may not have come across sine to the 4t or sine to the 5t, but it's really just a mathematical shorthand. So sine to the 4t means sine t to the power of 4. So mathematicians, to save the effort of writing brackets around every time they want to do the power of a trig function, they created a shorthand so they can write a little 4 after the sine, and that's what that means. And similarly for cos or tan. Right, so this requires a process called integration by substitution. So this integral is too complicated to do it in one go. We have to do like a trick basically to turn it into something that's easier to do. And in this case, the trick will be to make u equal to, so we're creating the u, that's our thing that we're creating, and we're going to make u equal to sine t. Now I'm choosing sine t because that's the one that we're raising to the power of. Now we need to differentiate it. So du by dt is equal to cos t, because when we differentiate sine t, we get cos t. And then we need to rearrange this expression to t equals. So du equals cos t times dt. Divide by the cos t. The t equals du divided by cos t. Now, technically, mathematically, that doesn't necessarily make a proper sense because du by dt isn't a traditional fraction. However, it's a convenient shorthand to make sure that when we switch from doing everything in terms of t to doing everything in terms of u, as our substitution will do, then we make sure we replace the dt with the right thing, because it will have an effect and change the dt, and the dt will fundamentally be replaced with du divided by cos t. When we change from t to u, it will also change the numbers on the limits. So what we need to do is we stick t equals pi over 2 into this formula, and we get a corresponding u value. So u equals sine of pi over 2. You'll need to have your calculator in radians to do that. And again, to stick your calculator in radians, we press shift, mode, and 4. So if you do that, sine of pi over 2 in radians is equal to 1. If we stick t equals 0 in, u equals sine of 0 equals 0. So actually we change the limits into something much nicer. So doing the substitution, so the limits pi over 2 and 0 become the limits 1 and 0. Sine to the power of 4t, well, that means sine t to the power of 4. Sine t is now u, so it's u to the power of 4. Times cos t, and then the dt gets replaced with du over cos t. But the cos t's cancel, because cos t divided by cos t cancels, so we get the integral of between 0 and 1 of u to the power of 4 du. And that integral is much easier than the integral we started with, which is the point of doing integration by substitution. Now we can integrate using the normal polynomial rules. So u to the 4, we add 1 to the power, 4 plus 1, we divide by the new power, so divide by 4 plus 1, limits 1 and 0. Let's tidy that up a bit. 4 plus 1 is 5. So replace both the 4 plus 1s with 5s. We then, as we've done with all the definite integrations, stick the top number into the formula. So 1 to the power of 5 over 5. Minus, we then put the bottom number into the formula, 0 to the 5 over 5. And if we calculate that, we get 0.2. So stick in the calculator, we'll get 0.2 metres as an answer. So again, this is very, very complicated maths. At the very least, you'll need to be able to follow this process through, but with the numbers that are actually in the assignment, which of course are not going to be exactly the same as the numbers here. So best of luck.